But we're going to see questions, spot where they're from, do questions. Okay? That's what we're doing today. So we look at this question. This question screams Venn diagram. We agree? Which falls under mutually exclusive or not mutually exclusive lesson. Remember, you actually only have 4 lessons in this unit. The first one was odds in favor, odds against, probability from odds probability, right? The second lesson was perms and cons. So it looks like a perms and cons question. You do the top after the word probability. The bottom is total no restriction. The third lesson was mutually exclusive or not. So there is Venn diagrams, where you could get a Venn diagram where it's just a plain old Venn diagram, then you have to divide by the total to get probability. Or you could get a probability Venn diagram, which just gives you the probabilities right off. I don't know what you're doing, and I don't know who those are, but those are, like, are you actually? You guys are bringing your glasses today?
Yeah.
This is good.
Prescriptions.
I like it.
Because.
He doesn't like seeing. It's okay. Okay.
It's for losers.
Yeah.
You guys are nerds.
Yeah. Mutually exclusive and not mutually exclusive is the other ones where I do one thing. So you could roll 2 dice at the same time. What's the probability it's this or this? You could take out 1 card. What's the probability it's this or this? You could take out 1 marble. What's the probability it's this or this? Spin 1 spinner. What's the probability it's this or this? Flip 1 coin, right? You're doing 1 event. And what's the probability it is this or this? Mutually exclusive means no overlap. Not mutually exclusive means overlap. If you forget which one is which, remember it's alphabetical. You paying attention?
Yep.
So, M, then N, correct? Alphabetically, that's how it works. This one is the one with overlap because I'm subtracting the overlap on it, right? So if you forget which one has overlap and which one doesn't, well, the one where we're subtracting the overlap does. So mutually exclusive, not mutually exclusive. M, then N, alphabetically. Okay? You're given the formula sheet so you can look there. Now, those are the 3 things we did so far. The one today is going to be independent or dependent. It's where 2 events happen. So I flip a coin and I spin a spinner. What's the chance it's this and then this? Right? 2 things happen. Yeah? Yeah. So, we're going to go through this stuff today first. So here it says, there are 30 people in a class, 15 are in math, 17 are in English, 3 are in neither. That's a Venn diagram question. We agree? Venn diagrams, most of the time, are not mutually exclusive. Because the only time they are mutually exclusive is if you have a circle, and then another circle, and there's no overlap between them. Most of our Venn diagrams have overlap. Do you agree? So, we're going to look at this one first. You should have had these completed. If you didn't, that's on you. But we have 30 people in a class total. Now I need to find the and first. If the and is 0, I have 2 Venn diagram circles that are not overlapping and it's mutually exclusive. So here it says 15 people are in math, 17 are in English, 3 are in neither. So I know at the very least there's a 3 out here. How do I find the and? Well, I take 30 minus 3, so I have 27 left for the snowman. 15 put in tickets for math, 17 put in tickets for English. That totals to 32. But I only have 27 spots. We agree? So if I go 32 minus 27, I'm left with 5. Are these overlapped or not?
Yes.
Yes. So this is the in-between. So I go to my Venn diagram, and I draw an overlap, and I put a 5 in the middle, and I write this as math, and I write this as English. Now it says math has 15, so there's 10 in math only. 17 in English, so 12 in English only. When I add them up, what should they add up to? 30, do they? Yes. So this is a plain old Venn diagram question. How many are in English? Only 12. How many are in math? Only 10. How many are in one subject only? 22. How many are in at least one subject? 27, right? 3 are in neither. That's a plain old Venn diagram question. The only difference if it's probability is you're going to take all those answers and divide them by what? 30, the total. 30, that's it. That's all that changes with probability. That's it. Nothing crazy. So here it says, what's the probability of being in math or English? How many are in math or English? 27, because it's the snowman. 27 out of 30, which reduces to 9 out of 10. Now here it says probability of being in math and English. How many are in math and English? 5 out of 30, which reduces to 1/6. Being in math only. There were 10 in math only, correct? So it's 10 out of 30, or 1/3. Now we're dealing with odds. They can ask odds from a Venn diagram. Odds in favor of being in math. So if we have odds in favor of math, math comes first. What comes second? Not being in math. And what should these add up to? 30. They always add up to the total. We agree?
We agree.
So how many are in math? 15 are in math. 15 are in math. How many are in not math then? 15, because they should total to 30. So it's 1 to 1. It's equally likely that they're in math or not math from this class. This one wants the odds against English. What the heck just moved on me? Odds against English. So that means English would come second and the complement actually comes first when it's odds against. Correct? And what are they going to add to? 30. Your odds always add to total. So when we go look up at the English circle, the English circle is 12 and 5. So how many are in English? 17. So 17 is going to be my second number. And what's going to be my first one then? 13, because they add up to 30. Can 13 and 17 reduce? No, 13 can never reduce. So that's a plain Venn diagram question that I can link to odds as well. We agree? Do you see that? It should not be, the Venn diagram should not be the thing that hangs you up. You guys have done Venn diagrams over and over and over and over and over. Okay? Odds always add to total. Now that is just a plain Venn diagram question with probability added to it. What is this one now? A probability Venn diagram. We agree? Sounds like a Venn diagram, but it says the probability of this, the probability of this, the probability of this. The hint is that it's in decimals. Okay? Do we normally have Venn diagrams in decimals? No. So when it sounds like a Venn diagram and it says the probability of and it's in decimals, it's a probability Venn diagram. Probability Venn diagrams add to what? 1 every single time. That's what they're going to total. 1, 1, 1, 1. They don't have to give you the total here. They're going to total 1. So their odds, if I ask for odds, they're going to total to 1 as well, right? Because that's going to be the total. Odds goes out to total. So here we have people at a grocery store are surveyed on whether they ski or skate. Those are the two things we're comparing. They determined the probability of skating is 0.4. The probability of skiing is 0.65. The probability of doing neither is 0.05, right? Same exact thing as the previous one, but it's probability, so it's going to total to 1. I don't have to, the previous one I said the total was 30. This one I don't have to give a total, because when it's probability, it totals to 1. But I do know that I have a Venn diagram, and I do know, well, I might not, they might not overlap, but they probably will. I know that out here is 0.05. So then, knowing that the whole probability Venn diagram totals to 1, what do these circles total to? 0.95. We agree? So if I add up skating, which is 0.4, and I add up the probability of skiing, which is 0.65, it ends up being 1.05, which is a problem because the whole Venn diagram can actually only add to 1, so it's way over it, so I know there's overlap. But I'm not going to subtract 1 from it. I'm going to subtract 0.95 because that's what's left for the snowman, correct? Because 1 is the whole Venn diagram, and I took off 0.05, so 0.95 is left for the snowman. I subtract them and I get 0.10, so that has to be my overlap because I'm over the 0.95, which I'm allowed. Okay? So this gets me 0.10. Then I need to label skating, skiing, so skating, does it say skating only? It says skating. It's 0.4. Do you agree? So how much is skating only? 0.30, yep. Skiing is 0.65. I take off the 0.10 and I'm left with 0.55. Now I have every single probability. I don't do any division. So the probability Venn diagram is actually easier because now I can just answer any question off of it immediately. So here it says probability of skiing or skating. So the probability of skiing or skating. What does the snowman add up to? 0.95. And I have the probability because it's a probability Venn diagram. Now we need the probability of skating or skiing, or skating and skiing. To be honest, if the question is set up like this is probably one of the most common questions to ask, skating and skiing, because you have to find it. It's not given to you. Or the other one they might ask is probability of skiing only or skating only, because you have to find the and first before you can get those. So skating and skiing is 0.10. We have the answer because it's a probability Venn diagram. Probability of skating only. Is 0.30. Odds in favor of skating. Odds in favor, whatever comes after it comes first. So skating comes first. What would come second? Nope. Not skating. It has to be the complete complement. So you can't say skiing because there are people who do neither and skiing, right? So we have to do skating and then everyone who's not in skating. Complements always are one and then everything else. The great thing about odds when you have a probability Venn is once you have skating, the other part is literally just what adds up to 1. So how many are in skating, in the skating circle? 0.40. And how many are in not skating? 0.60. 60, because these need to add up to what? 1. Now type this into your calculator. Go 0.4 divided by 0.6. Because the odds dots you can use as a division symbol. So go 0.4 divided by 0.6. Yeah. 0.4 divided by 0.6. And then math, enter, enter. What does it reduce it to? 2 to 3, right? So they could give it as an odds without a decimal. So this was in the mutually exclusive lesson or not mutually exclusive. Both of these Venn diagrams are not mutually exclusive because they had overlap. The other half of the lesson was I choose one option. What is it, this or this? Here it is. So determine the probability of the following. Determine if it's mutually exclusive or not from a deck of cards. I choosing one card. Determine the probability. Okay, I'm choosing one card. One card and the word or. The moment it has an or, I have to decide if it's mutually exclusive or not. And why? Because probability using an or is the top two formulas. Mutually exclusive, not mutually exclusive, correct? And is going to be the bottom two, independent or dependent, which are actually alphabetically backwards. Independent, dependent, so it'll be I before D. But these ones are the right way. So I'm choosing it. One card, what's the probability? It's a king or a 3. Are there king 3s in the world or 3 kings? No, there's not kings that have 3s on them and there's not 3s that have kings on them. So these are mutually exclusive or not? They're mutually exclusive. So we want the probability of a king or a 3 And remember, when it's mutually exclusive, you just do the two probabilities. Or means we do what? Or means we do what? Add. Or and add are always together. So we need the probability of a king plus the probability of a 3. How many kings are there? 4 out of 52. How many 3s are there? 4 out of 52, which gives us 8 out of 52. Which gets us 2 out of 13, I believe. And we leave it as an exact value unless it says to the nearest hundredth or tenth. Then we have to divide them. If it says to the nearest law percent, like say tenth of a percent, we have to take the answer, we have to divide it, and then do what to it? If it says percent.
Times by 100.
Times by 100. Then round. Right? So let's try this one out. Go 2 divided by 13 in your calculator. 2 divided by 13 gets us 0.1538. I want it to the nearest tenth of a percent. So we're going to times it by 100. And I get what to the nearest tenth of a percent? 15.4%.
That's my boy. No more.
So we want the probability of a queen or a heart, mutually exclusive or not.
Not.
There are queens that are in hearts, correct? There is a queen of hearts, is there not? So it's not mutually exclusive, which means I'm going to count the queen of hearts twice. So we're going to do the probability of a queen or a heart equals the probability of a queen plus the probability of a heart. And what do I have to remember to do? Track the overlap. Find it.
I don't think you did.
He's got it.
I'm trying to find it.
It's perfect.
Oh,
Yeah, he
Nice try, pal.
It's on Thursday.
It's the sitting behind me. I remember that.
It's the day before.
I thought it was wrong. It was the day we were working on the time.
No, then maybe Thursday he wasn't here. I can't keep up. All right.
My memory is.
So what's the probability of a queen? 4 out of 52. And a heart? How many hearts are there? 13 out of 52. Now I counted the queen of hearts in this first one. I counted the queen of hearts in the second one. So I've counted it twice. And so I need to take off the queen of hearts, so 1. So I get 16 out of 52, which reduces to 8 out of 26, which reduces to 4 out of 13. All right. No. Okay, we're flipping to the second page.
here you are, James.
Okay, so we have a club or a black card. Mutually exclusive or not mutually exclusive? Not. And we only have to state mutually exclusive or not when it has the word or. So not mutually.
That door says a word on.
Okay, so when it's not mutually exclusive, we can do the probability of a club or a black card. And not mutually exclusive means we use the second formula, alphabetical order. So probability of club plus the probability of a black card minus the probability of a club and the black card. So how many clubs are there? 13 out of 52. How many black cards?
186.
How many clubs are black? All of them, correct?
Yeah.
So we counted the black clubs here and the black clubs here, so we have to take off 13 of them. So it's actually just half the deck. Which, you guys, it should make sense. What is the chance of me getting, probability of me getting a club or a black card? Well, the moment I get to pick the black card, it's half the deck, right? The clubs are included in on that, so I still have a 1 and 2. When it's or, not and. Because I'm asking you, I pick up one card, what's the probability this card is a black or a club? Well, half the deck is black or clubs, so 1 out of 2. Face card or heart? Mutually exclusive or not mutually exclusive? Not. Because there are 3 face cards that are hearts. So we have probability of a face card or a heart. Because it's not, I have to take the probability of each, add them, and then subtract off the overlap. How many face cards are there? 12, because there's 3 in each suit, Jack, Queen, and King. And there's 4 suits, so it's 12 out of 52. How many hearts are there?
13.
How many of those hearts are face cards?
3 of them.
3, the Jack of Hearts, the Queen of Hearts, and the King of Hearts, correct? So we have added 3 in both of them. We've counted it twice, so we have to take 3 back off. And so we get 22 out of 52, or 11 out of 26. So mutually exclusive can include the Venn diagrams. It can include taking one card out, spinning one spitter, whatever it may be, and it's probability it's this or this. Here's another one. This one happens to be determine the probability of the following, determine if they're mutually exclusive or not, from a spinner with 6 spaces. And they'll have to say that all 6 spaces are equally likely. They'll have to state that because you could have like one really large number 1 space and then it wouldn't work. So they're always equally likely. I'm spinning one spinner. What's the probability it's this or this? The moment I have this or this means that I have to check if it's mutually exclusive or not. So an odd or a 4. Are there any odds that are 4s? No, so this is mutually exclusive. Remember, you want to do good on this test because it falls under unit tests and it can pick up your other ones.
Oh, yeah.
Wow, I forgot about that.
So it's probability of odd or a 4 equals just the probability of odds plus the probability of 4s, and I don't have to actually subtract because there is no overlap because they are mutually exclusive. How many odds are from 1 to 6? 3 out of
6.
6. How many 4s are on there?
1.
1 out of 6. Now some people want to reduce these. Don't reduce them till the answer. Right now you can only add fractions that have common denominators, correct? The moment you start reducing them, you're kicking out your common denominator. You're going to have to put back in the common denominator in order to put them together. So reduce at the end. 3 plus 1 is 4 out of 6, which is 2 out of 3, which makes sense. Because if I had a spinner with 6 pieces, 1, 2, 3, 4, 5, 6, and it's odd or a 4, that's this one, this one, this one, and this one, which is how many? 4 out of 6. Right? You could actually visualize. Evens are multiples of 3. Are there any evens that are multiples of 3?
Yes.
Even is 2, 4, 6. Multiples of 3 are 3 and
2.
3 and 6.
That's a factor.
Still not of 3.
What?
2 is still not a factor of 3.
Whoops.
So, is there overlap? 2, 4, and 6, and 3 and 6? Is there overlap? Yes. So if there's overlap, these are not mutually exclusive. So I have to subtract off the overlap. So I get probability of an even or a multiple of 3 equals the probability of even plus the probability of a multiple of 3 minus the probability of even and a multiple of 3. So probability of even, 3 out of 6. Multiples of 3, 2 out of 6. But I've counted what twice? I've counted the 6 twice, correct? It's in both. So what do I have to take off? 1 out of 6. So it's 4 out of 6 or 2/3. Odd or a factor of 12. So I always list my options. Odd is 1, 3, 5. What are factors of 12 on the 1 to 6 wheel?
3 and 4 and 6.
1, 2, 3, 4, and 6. So everything but the 5. Is there overlap between these two options?
Yes.
Yes, the 1 and the 3. Correct? They're counted in both. Yes? So it's not mutually exclusive.
So it's 100% then?
Nope.
Yes.
Nope.
Don't disagree with the team.
There's a 100% chance.
Maybe.
Yeah.
No.
What's the chance? You're wrong. Let's finish this question.
It's one of those guys who goes into the movie and then he just tells you like all the other guys. Sure. Probability of odd or factors of 12. Let's see what we get. Justin.
Can I go with him?
Not with him, but you can go too.
Can I go at the same time as him?
Yeah. Probability of odds plus probability. No.
Once they get back.
Yeah. Okay, guys. Shh. Probability of odd and factors of 12. So how many odds are there? 3 out of 5. How many factors of 12? 5 out of 3 out of 6. 5 out of 6. And then how many odds that are factors of 12? 2 out of 6. So we get 6 out of 6, which is 100% probability. And the reason why Justin saw that is because if you actually shade in each region that you counted, correct? You would count 1, 2, 3, 4, 5, and 6. So every region would be shaded based on odd and factor. That's why he got 1. All right. So, however, if your answer is 1 and it's a written response, make sure your phones are away. I'm not doing this for my benefit. If it's a written response and you just write 100%, or you write 1, how much marks are you getting? Luckily, 0.5. That's about it. So you need to be able to use the formulas, right? Okay. Here we have a committee of 18 people, 8 boys, 10 girls, want to form a subcommittee of 5 people. What is this screaming? Combinations. Now, even if I don't do anything, if it says, if I just go do it as a combination, that would actually get me the top, correct? You just have to know when it's probability, we divide by the bottom, no restrictions. And by no restrictions, I mean no restrictions after the word probability. So here it says, we have a committee of 18 people, we have 8 boys, we have 10 girls, we want to form a subcommittee of 5 people, correct? That information before the word probability affects the top and the bottom. We agree? The bottom just isn't affected by like a certain number of girls or boys because that's the only information that affects my bottom. 18 people, 8 boys, 10 girls, I want a subcommittee of 5 people. So what's going to be on the bottom of this? 18C5. Why is it a C, Leland? Yeah, there's no presuppositions. There's no jobs for these 5 people, right? So it's a C. Anything after the word probability affects the top. So after the word probability, it says a subcommittee with at most 2 girls. At most 2 girls means I'm getting cases, correct? Let's figure out the cases over here. So at most 2 girls means 2 girls or
No girl.
or 0 girls, right? So if I said I need at most $2 when I walk into the store, I need $2 or less. So I need 2 girls or 1 girl or 0 girls. I'm just laying the concept over here. But each of these committees still needs to have how many people? 5. So I need to supplement 2 girls and what do I need on this one? 3 boys. 1 girl and 4 boys, 0 girls, and 5 boys. Do I actually have to list the 0 girls? No. So you often won't see that option, okay? Because when you take the certain amount of girls, choose 0, that's one way, it doesn't affect it. Can you put it? Sure. But if it's a multiple choice and it shows you the worked out solutions and the 0's not there, please don't not pick it and be like, wow, it's wrong. It's actually right. So how do I guarantee getting girls? Choose them from the girls. So I have 10 girls. So I go 10, C, 2, and means I multiply. And then boys, 8, C, 3, or means I add. Yep. 10, C, 1 for girls times 8, C, 4 plus, I don't have to go 10, C, 0. If I wanted to, I could. But they're probably going to have just 8C5 back here. This is the standard of excellence question. Although we've practiced it enough, I feel like you guys should all be able to get it. I feel like this should be a standard of excellence that people should be able to do, at least and at most. Okay? When you type it in, what did you get? They'll often ask this one to the nearest percent, or they'll just reduce it. So when people type these ones in, they'll often type in the top divided by the bottom, but often they'll just type them in separate. So 10C2 times 8C3, 10C2, arrow up, times 8C3 plus 10. And you know what? The great thing about these calculators, they do order of operations. So they'll do these first anyways, so you don't have to put them in brackets. 10C1 times 8C4. Everyone should practice putting it in because just remember if you have these fancy ones to arrow up, which I haven't been doing and therefore having to repeat. So on the top I'm getting 2,646 over 8,568. I can divide them. And I get 0.30. I could have this, 31. If they say to the nearest hundredth, it'd be 0.31. If they say exact values, it'd be 21 over 68. If they say to the nearest tenth of a percent, it's going to be 30.9%. So there are 3 solutions here that they could ask. If they ask for the nearest hundredth, just plain old nearest hundredth, 0.31. If they ask for exact value, 21 over 68. If they say nearest tenth of a percent, it'd be 30.9%, right? So it just depends on what they ask for. And that's one of the errors that they say that you guys struggle with, 30-2 in general, is on the probability unit, is giving the wrong answer even though you got the right answer, just because you're not doing the rounding rules properly. Which we don't want that getting us. Okay, this one people get stuck on. I specifically picked this one because people don't know about the restrictions because they say, when I say total no restrictions, I mean total no restrictions after the word probability, right? So make sure you're paying attention. So we have a 4-digit code, which cannot be repeated. Did that happen before the word probability? Did cannot be repeated happen before the word probability?
Yes.
Yes. So this affects the top and the bottom. If it happens before the word probability, it affects the top and the bottom. So we have a 4-digit code, that's on the top and the bottom. It can't be repeated, that's on the top and the bottom. Okay? Do we see that? Then the word probability comes. Do you see that? Determine the probability. So I'm going to stop and I'm going to do the bottom first. So on the bottom, I have a 4-digit code. 1, 2, 3, 4. The only rule I have here is it can't repeat. So what do I have for the first blank? How many digits? 10, then? Okay, cool. After the word probability affects the top. We agree? If you remember that, these perms and coms questions are not ridiculously hard. What comes before the word probability affects the bottom and the top, technically. But you can do the bottom right away. And then you go to the probability and maybe it gives you more rules. Determine the probability that the code contains only odd digits. Okay, cool, that affects the top. What still affects the top though? I can't repeat, right? Because that still affects the top. I'm still not allowed to repeat. But now it added more stuff. So I still have a 4-digit code. I still cannot repeat. But on top of that, I also can only use odd numbers. Okay? So what are my options for this one? 1, 3, 5, 7, 9. So how many do I have? 5. Then I box and hold because that's how I remember that I'm getting rid of a number. I can't repeat. So how many are left for here? 4 then. So let's go through the answers again. So we get 5 times 4 times 3 times 2, 120 over 5,040. So I can ask for an exact value, which would just be dividing them. One over 42. Triangle 1 divided by 42. And as to the nearest hundredth, it would be 0.02. Or I could ask to the nearest tenth of a percent, times it by 100, and they'd give me 2.4%. You have to read. You have to read what we're asking for. Okay? And you have to be able to do all three. You have to be able to reduce fraction. You have to be able to give me to the nearest hundredth or tenth. You have to be able to give me to whatever percent. I could have asked to the hundredth percent too. It'd be 2.38. I can ask anything that gets me 4 boxes. Nothing bigger. Okay, then we go back to the first unit, first lesson. We worked our way back. See, we did mutually exclusive, not mutually exclusive, firms and comms, now odds. These are the 3 lessons we learned. This is all we've learned. I know it seems like it's a lot, but it's actually not. You just have to be able to do the different things. It uses a lot of previous information, which is what rooks people in some ways. So I can give you a probability and ask for odds. So here's the probability that it will snow. The probability of snow is 0.75. When it's an odds question, I immediately find the probability that it does not snow as well. So probability it snows is 0.75. The probability it doesn't snow, go pick that up, is what? 0.25. Complements should add to what? 1. Now why did I get the complement? Odds are the probability and its complement, correct? Either probability of it and its complement second, or its complement first and its probability second. Odds in favor, the probability of it comes first. Odds against, complement comes first. So here it says odds against snow. So the complement comes first. So what is not snowing? 0 decimal and snowing. How do we reduce this so that it's not in decimals?
1.
Yeah, but how do we reduce it if we can't see that? 0.25 divided by 0.75 in our calculator. And it's 1 to 3. Now here it says odds in favor of not snowing. So not snowing comes first. You have to watch yourself. They can do the complement as the word. Odds in favor of not snowing. So odds in favor, whatever comes after it comes first. Odds in favor of not snowing first, snowing. Wait a second, it's the exact same question, right? Just asked differently. Now they want the probability it will not snow. Well, that was easy. Then we're going to flip to our notes. Everyone's opening their notes. So this is the last lesson that you're going to learn. Remember, I just told you on Thursday before Christmas, we're going to go over rational word problems that we've known how to solve. It's just looking at a particular rational word problem. This is your last new lesson of the year. Okay? So tomorrow we're reviewing, test on Wednesday. Okay? So I will send you home with some questions tonight to work on for tomorrow so you can practice something tonight as well. We'll go through those at the beginning and then we're going to review. Okay? So, independent events and dependent events. Now, I told you this on your formula sheet. They're actually not alphabetical. So, mutually exclusive and not mutually exclusive are alphabetical. These are independent, dependent, so they're actually backwards. Now, what the heck does independent mean? Independent events, so mutually exclusive means I do one thing, what's the probability it's this or this? So I roll a dice, I flip a coin, I spin a spinner, what's the pull out a card, what's the probability it's this or this, okay? Independent and dependent is and. It's two events happening. So I can pull out one card and then pull out another card, what's the probability it's this and this, okay? I can spin a spinner and pull out a card, what's the probability it's this and this? I can take out a marble out of this bag, take a marble out of this bag, what's the probability it's this or this? You have to decide if it's independent or not, because could I do the events out of order and it wouldn't change the probability? Then they're independent. What does that mean? Well, example. If the first thing I do is I spin a spinner and the second thing I do is take out a card, does it matter what I get on this spinner? Does it affect the card? No, those are totally independent events. That means I could multiply the probabilities this way, or flip them and multiply them this way, and I'm going to get the same answer. We agree? So if I toss a coin and I spin a spinner, do they affect each other? No. I roll a dice and I spin a spinner. Does it affect each other? Okay, what about this? I roll a dice and then I roll that same dice again. Does the probability of this one affect this one?
Yes.
Do I take a piece off the dice after I roll it? No. So does it affect it? No. If I roll a 6 on the first one, it's equally likely to roll a 6 on the next one. Correct? Because I'm not taking the piece off of the dice. Same thing goes with spinning a spinner. I spin a spinner, I get a 6. I spin a spinner again. Oh no. I spin a spinner again. Does it affect it? Do I take a piece of the spinner off the first time? No. A spinner is a spinner. You can't like take a piece of it off. Right? So anything that's like a spinner, a dice, or a coin are always going to be independent because I can't physically take the piece off after I do it. When I roll it, I have the same amount of stuff. Okay? What about a card though? What's the probability that's a king and then a queen? So I take out a king, and then what does it affect the next one? It does if I don't put the card back, right? So if I take out a king and I hold it, now I have how many cards left for this one? 51. I've totally changed it. That's dependent. This event is dependent on what the heck I'm holding in this one, right? So if it's a queen and then a queen, if I take out a queen and I'm holding a queen in this hand and I don't put it back, now I have 3 out of 51 chance of getting a queen the second one. So they depend on each other. The second event depends on the first one, what I'm holding in my hand. If I replace the card, if I take out a queen and then I replace it, and then I take out another queen, are those affected by each other? No. So if I say with replacement, they're independent. Because if I'm replacing the card, it doesn't matter what I got in the first one. I'm replacing it. I have 52 cards again. So without replacement is dependent. With replacement is independent. Another one that people get messed up, I have a bag of marbles here, and I have a bag of marbles here. They're not intertwined. It's just one bag of marbles here and one bag of marbles here. Correct? Okay, what's the probability of getting a blue marble and then a blue marble? Do they affect each other? No, I have a totally different bag of marbles here and a bag of marbles here, correct? I take out a blue one on this bag of marbles, and now I just go to a completely different bag of marbles and take a marble out, right? So those are independent events. We agree? Now I take those 2 bags of marbles, I pour them into one bag of marbles. All right? I take out a blue marble, I hold it in my hand. Now does it affect my next amount? If I'm holding a marble in my hand? Does it affect it? Yeah, I'm holding a marble. Instead of there being 10 marbles, there's now how many? 9. Okay, what if I take a marble out and I put the marble back? Now I take out a new marble. Does it affect it? No, those are independent. So with replacement, it makes it that they don't affect each other. They're independent. So here it says independent events. 2 events are independent if the knowledge that one event has occurred has no effect on the next one. None. Like I replaced the marble back. It doesn't matter anymore, right? Dependent events whose outcomes are affected by each other. For example, if 2 cards are drawn from a deck without replacement, the outcome of the second event depends on the outcome of the first one. Whatever, I'm holding a card in my hand, right? I now have 51 cards. I've completely changed the deck. Okay, let's look here. We have a bag contains 9 marbles. 9 red, 3 green. This is bag A. If I can, I draw stuff because it helps me out. Then I have bag B. Bag B contains 9 black, 6 orange. Find the probability of selecting 1 green marble from bag A and a black marble from bag B. Instead of saying and, you could say and then, picking. And then. And means I do what with my probabilities? And what do I do with my probabilities? And add go together? Multiply. And add sound the same, but they do not go together. Never have they ever in this entire year, correct?
Correct.
So if it says and, we're always going to multiply. If you forget, look here. Probability of A and B, what's between them? A multiplication dot, correct? It literally tells you what to do on your formula sheet. So we're going to do probability of green. These are independent. Why are these independent events? If I take a green out of here and then a black out of here, why are they independent? They're totally different bags. They have no relation to each other. If I pull a green out of this one, it does nothing to bag B, right? So if they're independent, we follow the first formula, which is probability of A times probability of B, because these are actually out of alphabetical order. So it's independent, then dependent. So the probability of green times probability of black. How many green are there? 3 out of 12. Probability of black? 9 out of how many? How many are in this bag? I hope you know it's 15. I'm just going to guess that you do. Type it into your calculator. Not into your phones. Type into your calculator. So, there are 3 answers I could give here, depending on what they ask me. Exact values, 3 out of 20. Nearest hundredth, 0.15. Nearest percent, 15%. What if you answer the wrong one? How much marks do you get? None. So you knew exactly how to do the question. You showed all the work. It's a multiple choice, or it's a worst case, it's a numeric response, right? It's a numeric response, and you give the wrong answer. Didn't matter that you knew what you were doing. You didn't give the answer. It's a bubble sheet. It's a computer. It has no love for you. It will just give you a 0. Okay? Let's look at number 2. Here we have 2 seniors, 1 from each government class. Yeah.
So for like the answers, if you put all 3 that you did,
That would not work either. You have to give what they ask for. So if they ask for exact value, you'd give 3 out of 20. Nearest hundredth, let's say 0.15. Nearest tenth, 0.2. Nearest whole percent, 15%. Yeah, you can't give everything. Yeah. And you can box it and show them. And honestly, you can give, if it's percent, you can give all of them, because you're going to take this and you're going to show them that you're timing it by 100, like you're showing the steps. So that would be okay. Yeah. So here it says 2 seniors, 1 from each government class. So we have class 1. We have class 2. Are these independent or dependent? Independent or dependent? Do the 2 events depend on each other, or are they independent of each other? Independent, because I have class 1, class 2, like bag 1, bag 2. So class are randomly selected to travel to Washington, D.C. Wes is in a class of 18 students. Maureen is in a class of 20. Find the probability that Wes and Maureen will be selected. if I multiply West by Maureen or Maureen and West, does it matter? Because they're independent, order doesn't matter, correct? They're pulled out of two totally different classes. So if I want the probability of Wes and Maureen, and means I use the intersection symbol, and it's independent, so I use the first formula, which is just the probability of Wes being picked, and then, which is multiplication, the probability of Maureen. So how many, Wes is how many out of 18? 1 out of 18. And Maureen is 1 out of 20. And sometimes in multiple choice, that's actually how they show the answer, as fractions. A little bit, more people are going to get it correct because they're showing you actual, like, worked out solutions, right? How you could possibly get these. But they're probably going to have a plus sign in between them as well. And by probably, I mean they're going to. So whenever the problem is that it's a multiplication or a plus sign, they will always give you the answer to the exact same answer with the wrong sign in between. So if you don't know your work, and you don't know and is multiply, and you don't know or is add, you don't have a 50-50 guess anymore. You're literally just, it's bad, because you could pick the wrong answer every single time and it will show up. So you need to know that and add do not go together. And if you forget, this is an and symbol because it can make the word and it's multiply or it's add. So, this one is the answer, 0.002777, and it keeps going. So if this was a multiple choice answer, they're either going to leave it as 1 over 18 times 1 over 20, or they're going to give you the answer as a percent. Because they're probably not going to give 0.0027. So if they want it as a percent, you're going to times it by 100. And if they want the nearest tenth of a percent, people get thrown off by this one because they'll see 0.277 and now they'll say 27.8. You times it by 100. When you times it by 100, you got 0.2777. So what is it as a percent actually to nearest hundredth? 0.3%. You have to watch yourself. Don't times it by 100 again. It's not 27.8%. It's 0.3. Okay, then we're flipping over. Yeah. Yeah. Okay, dependent. You know something's independent immediately if it's tossing a coin, rolling a die, spinning a spinner, events with replacement, events where it's coming out of 2 bags or 2 classes. Those are always going to be independent. The reason why is because the object is replaced. So if I roll a dice, I can't literally take the side off. So when I roll the dice again, I have same amount of probability, right? When I toss a coin, if I get a head on the coin, I'm not ripping the head off and now I only have a tail. I still have a head and a tail left. So any of the objects where you don't physically take the piece off, you are replacing it, correct? Because you didn't take it off in the first place. And if it's with replacement, it's independent. So coins, die, spinners, events with replacement are all replaced events. Therefore, they're independent. Dependent are whenever it says without replacement. It has to say without replacement. If it doesn't say without replacement, you assume you're replacing it. Okay? So the sample space will change. Example, picking a card and keeping it before picking out the next card, you have 51 cards, right? You've totally changed your sample space. You've totally changed your total outcomes. So, what the heck is the dependent formula? Well, the dependent formula is this. Probability of A and B equals the probability of A, and then it's this weird symbol. Probability of B slash A. It's this little like straight up and down line. I don't know why I made it a slash. Now all this means is B given that A happened. All this means is B given that A happened. That's all it means. So it means what you would do if you were holding a card. Okay, what's the probability of a king given that I'm holding a king? That's all it means. What's the probability of queen given that I'm holding a queen? So this is the dependent one. So we'll show the formula. Here it says a card is pulled from a pile that consists of, and they'll do this because then they don't have to show the card array, because as long as they make a whole new deck of cards for everyone, it's not lopsided for the people who do know cards and the people who don't. Okay, so they'll do this. It's pulled from a deck that consists of 5 black, 6 purple, 8 yellow, and 1 green. Okay? Then here's the key thing. Then without replacing the card, another one is pulled. Without replacing instantly means dependent. It means the second event depends on whatever the heck the first event was. So if I have probability of yellow then blue, that means probability of yellow and then blue. Now this is without replacement, we agree? So we have to use the dependent formula, which is the probability of yellow times the probability of blue, and then what do I have to do? Straight up and down line, given that the first card was yellow. That's all that means. What's a blue, given that I'm holding a yellow in this hand? That's all that means. So what's the probability of yellow? How many cards are there in the whole deck? There's 20. So it's 8 out of 20. Times, now I'm holding a yellow card here. I'm not replacing it. It's right here. It's in my hand. Yes? Now I need the probability of a blue, given that I'm holding a yellow. How many blue are there? And by blue I mean black. I don't know why I'm saying blue. How many black are there? 5 out of 19. What am I doing here? I'm holding a card. I did not replace it. Did it affect the top? No, because it's a yellow. Did it affect the total though? Yes. So it's black given that I have a yellow. So 5 out of 19. So it's 2 out of 19 or 0.11. All of these are dependent because the very top direction says I'm not replacing the card. The moment I'm not replacing it, it's dependent. I'm holding one. It's going to totally change your total sample space. So this one wants probability of purple and purple. So now I'm going to do probability of purple and then probability of purple given that I'm holding a purple. It's a lot of P's. So what's the probability of purple? 6 out of 20. And now I'm picking a purple, but I'm holding one. 5 out of 19. If I replaced it, pew, it would be 6 out of 20 times 6 out of 20, right? But because I'm holding it, I'm holding a purple, it reduces the purples to 5 and it reduces the total to 19. So this one is green and then black. So we need the probability of green and black equals the probability of green. I'm holding the green now. And then the probability of black, given that I'm holding a green. That's all that means. How many green are there? How many green? 1 out of 20. I'm holding a green. How many black are there? 5 out of 19. If we have 3 things, we're literally just multiplying 3 things, right? But I'm not going to worry about that. I'm just going to do number 4 and then we're moving on. So we want probability of green and green. So we want the probability of green times the probability of green given that I'm holding a green. Trick question. How many green are there? 1 out of 20. I'm holding a green. What's the probability of getting another green? So this is actually a 0% chance. probability of getting a green without replacing it and getting another green, not going to happen. There's one green, right? Then we're flipping over. Yeah. So here we have a box contains. So we have one box. And it contains 5 purple, 3 green, 2 orange. Now what makes this question independent? How could I make this question independent if I have one bag of marbles? With replacement. Replace the marbles. And the next one doesn't depend on whatever the heck the first one was, right? If I don't replace the marble, though, then it's dependent. If I have 2 completely separate bags of marbles, that's always independent, right? So let's read. 2 consecutive draws are made from the box without replacement. What is this? Dependent or independent?
Dependent.
Dependent, because they depend on each other. Because I'm not replacing it. So it's the probability of getting an orange and then a green. Well, if it's dependent, I do the probability of orange times the probability of green, given that I'm holding an orange. How many orange are there? 2 out of? How many? 10. Green, given that I'm holding an orange? I have an orange in my hand. What's it going to be? 3 out of? 9. That's 3 out of 45. Ooh, it's even smaller than that one. Okay, then we're scrolling. Look at another one. If you draw 2 cards from a standard deck without replacement, find king. It's without replacement. Is it dependent or independent? Dependent, right? Because without replacement. So we want the probability of a king and then a jack. So it's the probability of a king and the probability of a jack, given that a king was first. So how many kings are there? 4 out of 52. How many jacks are there? 4 out of 51, because I'm holding a king. I'm holding a king. Not sure if people aren't writing stuff down.
Oh, we are.
Oh, some are not. So here we have the odds that Ava will pass math are 4 to 1 in favor. Which one of these is passing? The 4 is passing, the 1 is not passing. We agree? Can we write probabilities out of those?
Yes.
Yes, because odds always add to the total. Probability adds to 1. Probability Venn diagrams. You're just getting it mixed up. Odds adds to total. So if I want the probability of Ava passing, what would it be? 4 out of what? 4 out of 5. Then what would be the probability of Ava not passing? Yeah, 1 out of 5. Okay, the next one says the odds that she will pass English are this much against. So which one is passing English? The 1 or the 9? The 9, because it says against. Passing English against. So this would be English and my complement would come first. So the probability Ava will pass English But I guess it should say math. Would be 9 out of what? 9 out of 10. And what about the probability of Ava not passing? Now I can ask you any question, and you can give me any answer, as long as you have all 4 of these things. Because I can ask you the probability of Ava passing both. I can ask you the probability of Ava passing English but not math, or passing math but not English, or failing both, right? And you have all the probabilities you need to multiply. Agree? So here it says, determine the probability to the nearest hundredth that she'll pass math and English. So probability of passing math and English. What's her probability of passing math? You have 4 things up there. What's her probability of passing math?
4 out of 5.
4 out of 5. And means I do what? Multiply. And add do not go together. They never have the whole year. They never will. This is her last lesson. I've proven to you that and never becomes and. So passing math, 4 out of 5. What's passing English? 9 out of 10. And they want to the nearest hundredth.
0.7.
0.17?
0.72. So 72.
Yeah, that makes sense. It should be high because she has a very high chance of passing both. Okay, this one says that she will pass math but not English. What do I do? Math? 4 out of 5. And not English.
So 1 out of 10?
Yeah. So it's 4 out of 50. Or 8%. 0.08. What about passing math or English? We're going to have to watch ourselves with the math or English. So we'd have to create a Venn diagram with that one. What if I said didn't pass either? What if I said didn't pass either? Didn't pass either would be 1 out of 10 times 1 out of 5, which is 0.02. So, catch this. Math or English. She can pass math or English, or she could pass both, technically, correct? So what's the only thing she can't do when it says math or English? She just can't fail. She can't fail both of them, right? What does the probability add up to? 1. So if I just take 1 and I subtract off her failing both, I'm actually left with 0.98, which is or. Because remember, this is just like a Venn diagram. Or is the whole snowman. We agree? And what does the probability Venn diagram add up to? 1. So if I just take off the people that aren't in the snowman, what's left over? The people in the snowman, right? So if I just go 1 minus her failing both, I actually get 0.98. I'm going to post a review in Google Classroom for you to work on tonight.